Rum comes from byproducts of the sugar industry like molasses. The Caribbean and Latin America produce much of the world's rum. Light rums are the base for cocktails like the minty mojito. Amber rums are medium-bodied and aged for flavor. They're often drunk straight, as is dark rum, the strongest tasting of all. This fine amber rum is the product of a long and complex process that begins with the harvest of mature sugarcane plants. The cut cane goes to a sugar mill where they wash it, then crush it to extract its sweet juice. They boil it down. This produces a kind of molasses that then goes on to a centrifuge machine that draws out excess moisture. Rum making really begins here, in these distillation towers. This is where ferment made from molasses distills into raw rum. To make ferment, molasses mixed with water and yeast heats in open tanks for about 30 hours. This converts sugar into alcohol. Here's a sample straight from one of these tanks. Notice that foamy top layer? That's fermentation in action. Before distilling the contents of the tank, technicians first test a sample. In this glass still, steam heats the ferment and releases alcohol vapors that condense at the top of the column. As they travel down the still spiral, the vapors cool and condense even more. The liquid that collects in the beaker is 80% alcohol. It's the same process inside the distillation towers, on a much larger scale. The ferment must reach 176 degrees Fahrenheit to distill into raw rum. Then it's stored in these 13,000-gallon containers until they test it for quality. These gas-powered boilers provide the steam heat for the distillation towers. Workers monitor the distilling towers day and night. This facility can produce more than 10,000 gallons of raw rum a day, all stored in these gigantic silos. From there, the raw rum goes into charred oak barrels. It's mixed with water and left to age anywhere from 1 to 12 years. The charred wood produces esters that give the rum color, flavor, and aroma. The longer it ages, the more intense the flavor. Technicians perform tests on the sample at the distillery's laboratory, closely monitoring the aging process. First, using a hydrometer, they measure the amount of alcohol in the samples to make sure it's in the standard 50% range. Next, they smell each sample to make sure the aromas are in balance. They keep a journal of all their observations. Quality control is the key to producing a consistent, flavorful product. Once it is aged, the rum is bottled. It's a fully automated process. First, they sterilize new bottles in a sodium carbonate solution. Then a conveyor moves them to a filling station that can process 150 bottles a minute. Rotating wheels deliver the bottles to a lever system that raises them up to the nozzles on pneumatic pumps. They fill up with rum, more than 72,000 of them each day. Next, aluminum bottle caps come down a chute right onto the bottle tops. A piston valve pushes down on the caps and tightly seals each bottle. Next stop, labeling. First, a spinning roller applies glue to panels set on a rotating wheel. The panels pass a dispenser and a label glues onto them. Another rotating wheel grabs the labels from the panel and transfers them onto the bottles. Sponges press them neatly into place. As the bottles convey out of the labeling station, brushes smooth out each label. Finally, the bottles lower into boxes 12 at a time to ship to customers all over the world. Tiffany lamps were invented and produced by designer Louis Comfort Tiffany, starting in the late 19th century. They were renowned for their elaborate stained glass shades, crafted entirely by hand. The term Tiffany has come to be used as a generic term for any lamp or hanging light fixture with a stained glass shade. This lighting company produces original stained glass lamps, as well as reproductions of renowned Tiffany designs. There's nothing machine-made here. Each and every creation is meticulously handcrafted. The lamp designer first draws a pencil sketch of the shade, then prepares a color rendition. He produces a pattern in the lamp's actual size and assigns a number to each pattern piece, then records by code number the specific glass they'll use for each piece. Next, they cut out the numbered pattern pieces, lay them on the corresponding glass, and trace them with a marker. Using a glass cutter, they score the trace lines and snap them. When a piece is too small to get enough snapping leverage, they grip the glass with special pliers called grozers. Next, they sand smooth the rough edges of the cut pieces, so they won't puncture the adhesive copper foil that goes on next. After wrapping each piece, they crimp the foil tightly, first with their fingers, then with a flat object. This design, like many, incorporates glass jewels. These come from glass suppliers ready-made. The next step is to coat the foil with flux, a chemical that enables solder to stick. Now, with a soldering iron, they melt tin and lead solder onto the copper foil. Initially, they just tack all the pieces together, completing one section of the shade at a time. Then they lay the sections side by side in a curved plaster mold. This bends them to the correct shape. More flux. Then with the soldering iron, they tack the sections to each other. Then solder the whole interior. Once that's done, they remove the shade from the mold and solder the whole exterior. Now they top the shade with a brass cap and solder that on. This lampshade design features dragonflies with brass filigree wings. After soldering the wings in place, it's time for what's called the final beading. A final soldering over the existing solder lines to make them even and rounded. Now they wash the shade in an antiquing solution, which dulls the shine of both the solder and the brass cap, giving the lampshade an aged look. In another department, they install what's called the light cluster, a rod with light sockets and a pole chain into a lamp base. They fish the power cord up the base and out the top. Then connect the cord to the wires coming from the sockets. They tuck in the wiring, apply thread locking solution, then screw the base closed. For the time being, they attach the finial that goes on top of the shade. And now, a light bulb moment. If everything works perfectly, the tags go on and the base gets its shade. The bases of the original Tiffany's were made of bronze. These, both for tabletop lamps and hanging fixtures, are cast from zinc, the same look at a fraction of the price. For safety reasons, aircraft engines have built-in redundancy features, like dual spark plugs and dual ignition systems, so that vital components have a backup. Rising gas prices and eco-awareness are compelling manufacturers to build aircraft engines that are more efficient and less polluting. Aircraft engines are remarkable pieces of engineering. To build a four-cylinder engine, a worker wraps abrasive tape around what's called a bearing journal on a crankshaft. Using a polishing jack, he polishes the journal to the correct diameter, which he verifies with a digital snap gauge. An operator then oils the journal and attaches a connecting rod. These link the pistons to the crankshaft, which turns to generate power. Then he applies gasket sealant on the edge of the crankcase and silk thread that acts like a gasket, so when the two halves of the crankcase are joined, the engine won't leak oil. He places a camshaft into one side of the crankcase and measures the clearance to make sure it's a tight fit. Then he oils it to ensure there is no friction. They place the crankshaft and rod assembly into the crankcase, then join the two halves together. To prevent the connecting rods from hitting the sides of the housing, they put on what are called torque plates. He adds a little sealant to hold a gasket in place, then attaches an accessory housing, which holds all the gears and hoses that are mounted on the back of the engine. He installs the sump that holds the oil supply, then attaches a piston to each connecting rod. Now he mounts a cylinder onto a piston and connects the parts to the engine. He'll mount and secure all four cylinders this way. He inserts hydraulic tappets and then shroud tubes. He attaches them to the cylinder using a retainer. He inserts a push rod into each tube and fits a rocker arm onto each rod, completing the cylinder and valve action assembly. He steam cleans the engine. Then he paints it with rust-proofing enamel paint. Next come the spark plugs, one on the top and one on the bottom of each cylinder. He grounds and then installs two magnetos. These devices generate the electricity for the spark plugs, which ignite the fuel in the cylinder. He attaches the spark plug wires from the magneto to the spark plugs, then verifies the engine timing. Next come the heat shields, the intake pipes, all the spark plug connections and drain tubes, and finally a fuel injector. An operator then attaches a testing propeller to the engine to keep it cool during testing. He runs the engine using controls like a pilot would use and certifies everything from engine speed and temperature to fuel pressure and airflow. Hours later, he checks the oil filter for signs of foreign material or contamination. And this engine passes the test. A worker then puts preservative oil into the cylinders. This special oil safeguards the engine en route to the customer, whether they be general aviation manufacturers or individual owners. Once installed in the airplane, and after the standard pre-flight checks are done, the four-cylinder engine allows the pilot to take to the clear blue skies in total confidence.